So, hello guys, how you doing? So, I want to quickly demonstrate, sorry, I want to quickly demonstrate the interface we'll be using today. Um, like I told you that for us to run our code, we'll use an ID, right? And the ID I'm using today is Visual Studio 2010. So for us to start, we have to create a new project. So every time you want to run code, it sees it as a project. So you click on new project. So I'm using Microsoft Visual Studio 2010, right? You have to ensure that you are in the right environment. If you look at this side, left-hand side, you see is Visual C++, right? Because sometimes you might have other languages, maybe C# or any other language, and you are clicking. You can see that the interface, this is green, but C++, it's blue, right? So you have to take note of this. During exam period, some students might fidget and click on other language, right? So ensure that you are in Visual Studio, Visual C++, then go to Win32 console application. So what we're doing for now is console application. So give your project a name. So let's say tests 101. Test 101, that's the name of the project. And you have to note also where you're saving your work to. I'm saving it in my document, inside my document, Visual Studio 2010 project. And I'm asking it to create a folder for this solution. So click OK. So when you click OK, it will bring another dialog box for you. Then you click Next. When you click Next, tell it to give you empty directory. In empty directory, we'll write our code. It's more like a blank sheet of paper, right? And click Finish. Okay, so these initial steps is very critical for you setting up your platform. Then, so you can see it has created it for you. Look at it. Project creation successful. And by your right hand pane, you can see it has created several folders for you. So the next thing for you is you go to this source file, right? You can right click on add new item. You're adding new item. You can see here we have no place or scratch pad where we can write our code. Then tell it you want CPP. You want a CPP. You can just type source. So it will add you a source.cpp file. So you can see we have an interface where we can type our code. So we can start #include iostream IO stream. We close it using namespace std. So these are just more like the initial commands you have to put type. So as you go on in programming, you understand what each code means. So for now, just follow along. So I'm adding this to pause my screen for me. All right, so this is the basic code. So today, I just want to demonstrate to you variable declaration and initialization. I told you that for us to use to create a variable or to use a variable, you have to create it before you can use it. And C++ is a strongly typed language. That is to say, you have to create a variable before you use it, and you have to tell it what data type this variable is, what value will be stored in this memory location. So let's say we have 5 fundamental data type. I told you. So let's say int age. This is, so with this, we've created a variable called age of the type int. Every statement you make must end with a semicolon. You can see without putting the semicolon, it's already giving me, is highlighting that there's an error, right? Look at the error. When you moved your cursor on to the place where you have your error, you have expected a semicolon. So it's expecting a semicolon to tell you that's the end of the sentence or statement. Rather, that's the end of the statement. So what you've just done is you've created a variable in C++, right? So in the computer memory, it will reserve a space for you with the name age, an integer space, 4 bytes for you. But in this location, there's no value. So what you can actually do, you can now say age equals, let's say 10 or 100 as you want it. Then it means you've created a space and the value is 100. So you can try to display the value. The value of age is what? So I can is age. With this, I'm displaying the content. So what I'm cout is a keyword to help us to display to the screen. If you want to display anything to the screen, you use your cout command. So I'm displaying to the screen the value of age is, you can see, display age. Then you can run it. So it will display the value of age. The value of age is 100. Okay. Okay. The value of age is what? The value of age is 100. Now, let me quickly explain cout, the function of cout for you. Now, with cout, you can display. Now, we've included an header called iostream. Iostream is a library that contains functions to help you display to the screen, input or accept input to the system. So input output stream. So with cout, you can display to the screen. If you want to display a string or a bunch of characters to the screen, you type cout less down, then the characters you want. I love C++. Then, so you can then end it with a semicolon to tell it, oh, I'm done typing. So what you're doing is you're displaying to the screen, I love C++. So let me give you a brief pointer of what we're trying to do here. So just imagine our monitor. We have our monitor. We have our system. Let's say we have our system, our CPU, and we have our keyboard. Our keyboard is an input unit. So this is the monitor. This is the monitor. Okay. This is the keyboard. And this is the CPU. So anytime we are inputting from our keyboard to the CPU, then we use the keyword cin. Then with the direction of flow. So from the keyboard, where is it flowing to? It's flowing to a variable in the CPU. So from the keyboard, it's flowing to a memory location in in the CPU. So let's say X. But now, if we want to display to the screen, we use the Q cout. Then you have to reverse it because it's from the CPU now outside to the monitor. Then you use your less than X. Computer operates statement from the right to the left. So you're saying from the variable in your CPU, let it flow to the monitor. But here from the keyboard, let it go into the system. So that is that. All right. So for us to display to the screen or to the monitor, you put whatever string you want in quotes and say, okay, display. It means move this text, move it to the screen. Move it where? Move it to the screen. So it will display, I love C++. I love C++. So you can see, okay, if we have to display a number, you don't need to put it in quote. Just put it, just put the number there. It will display 3. It will display 3. All right, you can see, or you can carry out some multiplication, 3 times 2 times 3, and just display it to the screen. Okay, but now, if we have to reuse the value, it is important we save this value into a variable, into a memory location. So what we have to do is we can just say int value. We can then say, okay, value equals 3 times 2. 3 times 2. Then we print out the value. Okay. Then print out the value. Okay. So what we've just done is we've created a memory location. We've created a memory location, a variable called value. The variable is called value. The data type of value is int. It means it stored what? Whole number, an integer of integer data type. Any attempts, let's say, any attempt to store, let's say, a real number to that location, it might not give us an error, but it might warn us, and there will be what we call truncation. So let's see what that means. Let's see what it means. So we are having 7. What do we expect? We are expecting 7.5. but we are having 7. So what it does is integer stores whole number, and we are trying to store a real number with decimal place. We want to store it. So what it will do is it will cut off, it will truncate, cut off the decimal parts. And this can give us error, So just imagine you're multiplying, let's say your salary, you're incrementing it by 7.5%. And rather than you getting a whole value, let's say 75 million, you are getting 7 million. Sometimes some people can get pissed off with that. So it's very important to know the data type you're using. So the data type you're using. All right. So this, we've been able to save it as what? As integer. Then you can also, sometimes you can store a value as float. Float, like we said, stores what? Decimal numbers up to 6 to 7 decimal places, right? So a float with this, we should not have any error. So 7.5, you can see why it stores real number. Are we good? All right. Sometimes you can save a float as 3 exponential minus 2. 3 exponential minus 2 in a scientific way. It will still accept. It will still accept 0.03. Good. All right. So that's floating data type for you. Float is to help you store real number, and the decimal point is up to 6 to 7 decimal points, depending on your operating system. All right. So we have another one called double. Double can save. Double also stores real number up to 15 to 16 decimal points. So let's just say 1 divided by 3 divided by 3. Let's see. Let's see what the value will be. Oh, okay. Let's see. Okay. So we have a value. All right. So value double also stores real number up to 15 decimal places. So it's very important for us to utilize what the right data type for every variable we want to say. Okay. So we can also create a character variable. So let's say this stores D. So D. So for just a character, then you put it in single quote, not double quote. A single quote. Single quote. So we can see that. Are we good? So and also let's try for a boolean. Oh, sorry, boolean. Then we can put true. So the value boolean stores either true or false as 1 or 0. So true will be 1, false will be 0. False will be 0. Or you can also say 1. It will still accept it. That 1 means it's true. Okay. And 0 means it's false. What if you put any other number like 5? What will it give you? Let's see. So it still gives you 1. Why? Anything greater or equal to 1 is seen as true. So Boolean, we've been able to look at all our data, all our variable. So another one beautiful thing about variable declaration is you need to give a name that has a meaning. You can't just store a value as v. You can't create a variable and just say v, right? It's good, it's a variable, but it has no meaning. It has no meaning. So it's very good for you to use a meaningful variable name. So on this note, we'll stop and we'll continue some other day.